You can tell how far away a storm is by counting the seconds between the lightning and the thunder. Astronomers use a similar idea to study distant supermassive black holes. As gas swirls around a black hole, it flickers and flares, and that light echoes through the surrounding system with a delay. And by measuring those delays, this Osgrad PhD student and his collaborators can map the system's size and ultimately work out how massive the black hole really is from really far away.
So the accretion disk is sort of the engine of this entire system. All of the power goes from there outwards. But it's not static, it flickers a lot, and those flickers echo off all of the things they're powering. If this flickers, then all of the stuff that the light hits flickers as well. But there's a lag between the two because it takes time for the light to travel. If we can measure that lag, if we can measure that echo, then we can use it to measure how big the system is. We can use the reverberation as a ruler. That's why we call it reverberation mapping. Okay, so we've got a ruler. How does that help us work out the mass? Well, Earth orbits around the sun because while the gravity of the sun is trying to pull it in, centrifugal force is pulling it out. And that's a really straightforward balance. You can learn how to do this in high school. It's the same sort of trick we're using over here. The difference is that we can look at a planet, we can look at the Earth and see how quickly it's moving. Whereas with this, our speedometer comes from this thing called Doppler broadening. The same way that when a car is driving towards or away from you, the sound it's giving off gets higher or lower pitch. The same thing happens to the light coming off something that is moving towards you or away from you. Now, this broad line region, it's not moving towards you or away from you. It's sort of doing both. It's spinning around the black hole. And so the light coming off it, some of it is blue shifted coming towards you. Some of it is red shifted going away from you. And so when you've got a really clear single frequency of light, for example, the sort of emission lines you get from chemicals, those sort of smudge out as some of the cloud is approaching and some of it's receding. And that gives us our speedometer for how quickly the whole thing is moving. If you have a speed and you have a radius, which we get from that echo, then that's enough to work out how heavy the black hole is, using the same basic math as figuring out how fast the Earth has to orbit to stay in orbit around the sun.
Black holes may not shine, but their echoes are helping us understand how the universe built its biggest monsters.